most leaned tower in the world, Capital Gate Tower. Keeping Capital Gate Tower upright was a huge engineering challenge. There was not just one solution. To overcome the gravitational force, it took a whole range of pioneering techniques. And the task starts with the foundation on the deep underground. On one side of the building, the weight is going down into the ground. On the other side, however, it's been lifted out of the ground due to the large overhang. They use many concrete piles that work in two different ways. On the leaning side, half of the pile pushes the overhang forces into the ground. On the opposite side, the remaining piles anchor deeper into the bedrocks. They resist stretching forces trying to wrench the building out of the ground. Finally, forces of Capital Gate Tower are distributed into the piles from meshed concrete slab. Totally, it took almost 8 weeks, which could make whole construction schedule add up. Through this foundation process, the engineers learned that every single aspect of the building had to be custom to its special circumstances. We finished last week's presentation saying that Sheikh Sultan wanted the construction to be finished by an impossibly tight deadline. Actually, there was a reason for his haste. In less than 2 years, Abu Dhabi was about to host the World Future Energy Summit. Over 3,000 delegates from 50 countries and numerous press were about to come together to the Abu Dhabi National Exhibition Center, which was very close to our Capital Gate Tower. For Sheikh Sultan, it was a wonderful opportunity to show off his newly built tower, so by proving Abu Dhabi is at the forefront of innovation. This gave the construction team only limited time of 24 months to build a unique skyscraper. And as the foundation took up more than 8 weeks, the upper parts had to have a tighter schedule. Let's think. After constructing foundation, what will be the next part of the construction? To sustain the reign of the building, this was the most crucial part, even more important than the foundation. Starting from this week and the week after, we will talk about the core of the building, how it was planned and constructed. Inspired by a nearby desert landscape and its wind-shaped dune, architects have designed this curved leaning tower. However, it was another task for the engineers to think of a core to prevent the tower from falling over. It was a difficult task and the engineers were not satisfied with the job they have faced.
Structural engineer Mona Vasi knows it's a serious problem that must be solved.
When I saw this one, I thought it's impossible, it's not going to work. It's just some sketch, somebody left it somewhere. But I always think that the architects, it's easier for them to just draw something, but it's not easy for us to fulfill or satisfy their needs.
To explain how special the core of the Capital Gate Tower is, we need to first explain about conventional method of skyscrapers. Normal skyscrapers have a solid and slim vertical core to hold it upright. It is the core's rule to channel the load of the building to the foundation for them to support the building. However, with Capital Gate Tower's dramatic wind and curve, Capital Gate's design would cause a conventional core to bend dangerously. The pull of a massive overhang wants to stretch the core on one side, causing the concrete to tear apart. The leaning problem was impossible to resolve with conventional methods. The engineers needed to devise a completely new idea to defy gravity. They devised two groundbreaking rules for the core. We will talk of a first method this week. The first method is using the pre-cambered core. Pre-cambered method is a method originally used in slabs or beams. Its principle is to calculate the deflection caused by the load and camber it to the opposite direction of the deflection beforehand. By this, it could attenuate the effect of the beam bending The engineers thought that this was the perfect method to apply the core of the building. This attempt was never tried before on the buildings, and it was a challenge for the engineers. The plan was to build the core inclined to the opposite direction of the rim of the building. The engineers built the core bent, and as they added the slabs to the upper levels, the weight of the remaining parts pulled the core back into the vertical state. So basically, that whole vertical core would be in tension, and that gives it immense strength. The concrete that would have been stretched by overhang pull will be compressed and strengthened. The core with a curve in total shifts 350 mm, and its effect would be significant. This pre-cambered core came up 4 meters a week. Construction manager Les Fairchild was in charge of the building.
Probably the most complex core that I've come across. It's built at an angle, and effectively the core holds the whole building up.
Jump forming is most effective in sectioning the layers and floors of the buildings, so it is widely used in buildings over 5 stories. Among the jump forming methods, the construction manager thought of a way to transmit the concrete core materials and decided to adopt the automatic climbing formwork method. Automatic climbing formwork is a method which adds the hydraulic pump and rail to a normal formwork. The hydraulic pump helps transfer the materials to high places with speed. It cuts the requirement for the crane time to a great extent. Also, by letting the crane be used for the other construction works, it may help in reducing the total cranes required on the site. This makes the whole construction process more efficient and speedier. This type of formwork system is also widely used at the inclined angle using the rail. In addition, climbing forms an advantage operating in the strong winds. So, this was the most appropriate method to use in our Capitol Gate Tower, considering its incline and climatic environment. R. Harper's construction managing chose Doka's automatic climb formworks for the core construction. Moreover, based on R. Harper's very satisfactory experience on past projects, the main deciding factors for Doka were their technically convincing formwork solution and the comprehensive package of services designed to optimize all phases of forming operations. Doka Automatic Climbing Formwork SKE50. This is the easier but also the more flexible climbing technology system. It extends the used climbing formwork by adding automatic climbers. It can also be used for forming not only core but also facades. 78 Doka SKE50 and 1300 square meters of large area formwork top 50 were in charge of the core up to the height of 160 meters. Using this high-performing automatic climbing formwork system, they were able to make independent area of pouring concrete and reinforce the core. As it was a high building, the most critical point of construction was the safety of the building. Every formwork platform needed a fence, and it had steel ceilings installed in top 50 formwork. This system uses strong hydraulic system, and Doka pre-assembled it and provided it to the construction spot. This is how the construction team satisfied the standard of ADNEC safety and construction speed of the building. Next week, we will explain more about the core construction, how it proceeded through jump forming, and other measures taken to make the strong core. Thank you for listening.